Welcome to lecture 3 of this week 5 on kind of native token values, minting, etc. So this will be about actually minting policy, minting native tokens. So we will in this lecture see a very simple minting policy. We will also see how to build an off-chain transaction that mints tokens, and yeah, we will be able to run it by the end and mint our first native token. So just to recap a bit what I already alluded to previously. So there's in Cardano basically there's two types of two cases where you would run a smart contract. And one of them is the one we've seen so far, when basically you want to spend UTXO that is at a smart contract address. When you do that, then the respective script, the contract, would be run to validate whether you're allowed to spend that UTXO. This is what we've seen so far. This is a validation case. And the other case is the case of minting policy. So actually minting policy looks very similar. You also have kind of a validator. But this would be run basically not when you spend from a smart contract UTXO, but when you build a transaction that mints some native token with a certain policy ID. Then basically when you want to run that transaction, then the validator would be invoked, namely the one that corresponds, of which the hash is basically the minting policy from which you're trying to mint. Okay, and this can actually also be seen in the script context. If we look at here at the script context, then it would have a purpose field, and this script purpose is defined as either of the following. We're not interested in the last two for now, but so far we only seen the spending case, and now we'll get to know this minting case. So, okay, this is a bit abstract for now. Let's actually look at what a simple minting policy could look like. Okay, so we have one in this lecture folder here, which is called free.py. And you can see, okay, it looks somewhat familiar. We also have this kind of validator function here. There's one important difference, which is that previously this had three parameters, which was the datum, redeemer, and context. Now it's only redeemer and context. So why is this the case? So if you think previously, when we're spending from a smart contract the UTXO, then the datum that we put here was basically the datum that is attached to that UTXO we're spending. But now we said it's a minting policy, so we're not spending any special script UTXO, so we also don't have this datum. It doesn't make sense to put it there. Okay, so in that way it's different. Oh, and we can still have a redeemer, because also for minting you might specify some additional information, such as what token you want to mint, for example, or how many. And then we also check certain conditions here. So when we write them using these assert statements, so what are the things we check here? Basically is only one thing, namely what we just looked at. The script context has this purpose, and we just look at this purpose, whether it's of the minting type, which is what we want. Then we let the validator pass, and otherwise we let it fail. But we don't look at the token name or the amount, for example. So this from this policy, so from the hash, from the policy that is the hash of this script, we could really mint arbitrary token names with arbitrary amounts for free, basically. That's why it's called free here. So if we go back, let's actually compile and deploy this policy. So this works similar as compiling the scripts we've seen before. You can either use this OpShin build command or just use our build script, which we have here, which just internally also just runs the OpShin build, but already puts the stuff in the correct in the correct location for us. Okay, so let's actually run this. So we go back to our poetry shell, and then we change into the week 5 directory, and we take this command. Okay, and actually the result here, I think it's using this assets directory. So if you haven't had it before, you will have now this free, and it contains all the compilation output. So in particular the script with the CBOR hex encoding and the policy ID from which we will now be able to mint. So for this, of course, we need some off-chain code to construct the minting transaction. And this we have already implemented here. So if you open here the scripts mint.py file, you can see it will be somewhat familiar to the off-chain code we've seen before, but has some new components as well. So let me quickly walk you through. So we have different arguments like wallet name, token name you want, the amount you want to mint, and so on. We will use this same off-chain script for later for other purposes. That's why there's like different choices of the script here, but for us it will be the free one. And then if you look at it here, this is what we've seen before. You get the context here. We use like the Ogmios backend in the background, and then you take the payment address of your wallet that you gave, and because the transaction will have to have some output to contain our tokens, we also somehow need some input that puts some ADA in that we can use. So we just look at the UTXOs that are available and in this wallet, and we check that they have a certain minimum amount of ADA so that we can use them. Then here we basically just encode the token name as like a bytes object. And yeah, these cases are only relevant for the other scripts, but what we need to do for our case is basically obtain this ProtoScript object, which takes CBOR hex as input, which we just read from our script file that we obtained from the compilation we just did. And then we save here the hash, which will become our policy ID. And now maybe the interesting part where we actually build the transactions. So it's important here to have this add minting script function. So previously this is the equivalent to the previous add script input function, which we used for the spending case. And here we also provide the script that we just constructed, and there will be a redeemer, but actually you saw our on-chain code doesn't use the redeemer, so we can just put like a null redeemer here. And then there's this minting field, which we have not previously been using. So this is simply a field that contains the value basically that will be minted. So it's here in this multi-asset type, which is essentially nothing but a value that we saw before. And you can also see here we have this kind of nested dictionary we saw in the value type as well. And here the policy ID will be exactly the hash of the script, and the token name is whatever we gave there as bytes with the amount that we specified. And yeah, if this amount is actually non-zero, then we would also construct the output. For this, we need to add the input first, and then the output would just go to our own address and have basically the value that is some minimum amount of ADA, and then this value that we want to mint. Okay, and the rest is kind of standard. You add the required signers and actually sign and submit. And this is what we would actually like to do now. So let's see, we want to run this script. So let's just take the command here, and you see we want to use this Alice wallet that we generated earlier. We call our token free token. You can call it whatever you like. And we use this script free. So let's run this. Yeah, this usually takes a while because PyCardano basically needs to query UTXOs from the Ogmios backend and so on. But actually now it finished, and it gives us, so the transaction was successful, so that's nice. And it gives us the transaction ID, and it was actually submitted on the pre-prod testnet, which we're using here. So we can actually view it on the Cardano Explorer. Let's have a look. So actually this is the wrong network here because we are on pre-prod. So let me just change it to pre-prod. And we see already the transaction is appearing here, which was just appeared on the blockchain a couple of seconds ago. And we basically see, okay, we have an input here, we have two outputs, and actually one of them contains exactly what we wanted, namely this 2 ADA, and additionally this new free token that we minted. And also we can go into the mint section here, and we see also this token and the policy ID and so on. And there's a contract that has been invoked, which is simply the minting contract with the empty redeemer that we gave. And yeah, you can compare that. This will be exactly the CBOR hex of our script. And you also see now, okay, this is a script of type mint. So this is like the script purpose, basically. Previously we had the spending here. Okay, so let's go back. And this essentially concludes today's lecture. So I think you kind of saw the whole workflow from, okay, what is the idea of a minting script? How can we write a very simple minting script in OpShin? Then we can compile it, and we can actually write off-chain code that constructs the minting transaction. And we were able to submit this successfully and mint our first token. Of course, this was a very simple minting script, and there's a lot more you can do with the smart contract logic. And we will see a bit what are the options here in the upcoming lectures.